Right? We learned trigonometric ratios, trigonometric identities, trigonometric ratios of complement angles, all of this in the last chapter. Why was it useful? Where did we put trigonometry to use? Trigonometry's popular use, one of the most useful purpose for which trigonometry was used, was what was called as heights and distances. It was used then, it is used even now, to compute heights and distances between large objects, between objects which are further apart. For example, to compute distances between celestial bodies. If you had to compute the distance between Earth and, let's say, an asteroid, and Earth and another planet, for all of these purposes, for astronomy, it found great use. Not just now, it was used then by the Greeks, by our earlier astronomers, and it is finding use even to date. Let's find out what this is all about. Right? Let's say a person standing here is observing an object on top of the building. This place where he is standing to the base of the building is called the distance. The horizontal distance is called the distance in heights and distances. The height of this object, the vertical distance, is called the height of the object. He is observing an object from a lower level to a higher level, so the angle thus formed is called the angle of elevation. The distance that a sight travels, this hypotenuse of the triangle, as we will see, is the line of sight. Let's quickly do a schematic of it in a right triangle. AB is the height, which is a vertical distance. BC is the horizontal distance, the place from which the person is observing. How far is it displaced from the base of the object that he is observing? This is called the distance. BC is the distance. The hypotenuse is the line of sight, this distance that the sight travels. The angle formed, BCA, is called the angle of elevation. In this example, he was observing the object at a higher level from a lower level. The person could have very well been on top of the building and could have observed something down below. That's what is happening here. Someone standing on a stool looking at a ball down below. Now what we'll see is we'll be talking about angles of depression here. Right? Draw a line, this horizontal line level is parallel to the ground. You're observing an object from a higher level to a lower level. This angle formed is called the angle of depression. This is the line of sight. Well, it's represented in a schematic form as a right triangle. AB is the height from which this person is observing. He's observing it from A. The object being observed is down below. Draw a line parallel to the horizontal. Let's call it as AD. The angle formed between AD and the line of sight is called the angle of depression. Watch out for one very important thing. Many of us quite a few times think that angle ABAC, this angle is the angle of depression. It is not the angle of depression. Angle of depression is the angle formed between the line of sight and a parallel drawn to the distance, right? This horizontal, which is drawn parallel between this horizontal and the line of sight, whatever angle is formed, is called the angle of depression. Now, if you observe it from C to A, it becomes angle of elevation. If you observe it from A to C, it becomes angle of depression. Let's quickly put these two together and check out what happens. BC and AD are parallel lines. That's quite evident. AC is a transversal that cuts through it, which means that angle B and angle theta are nothing but alternate interior angles. In two parallel lines, alternate interior angles will always be equal, which means beta is equal to theta. So in any case, in any situation, if you look at it, angle of elevation will always be equal to the angle of depression. This is something that you can take for granted because of the fact that in two parallel lines, alternate interior angles will be equal. Beta and theta are alternate interior angles. Now, how do we compute? How do we actually use it in an exam? We'll be using the trigonometric ratios when we are solving questions. We'll be using one of these three ratios, obviously sine, cos, and tan. Let's check out when we will use sine. We'll use sine in first scenario when the angle of elevation is known. You know the vertical distance, which is the height. And what you actually need to find out is the line of sight. You know this, you're trying to compute the line of sight. In that case, you'll be using sine theta. Conversely, you know the angle of elevation and you know the line of sight. What you're trying to compute is the vertical distance, which is the height. You know this, you're trying to find this out. In these two instances, we'll be using sine theta. Because sine theta is nothing but opposite side divided by hypotenuse. Opposite side is AB, hypotenuse is AC, which in our example would, in this particular scenario, would be height by line of sight. So you know the angle of elevation, theta is known. One of these two, height or line of sight is given, and you have to compute the other, then go for sine theta. Now let's look at when we'll use cos theta. We'll use cos theta if angle of elevation is given to us and the distance, the horizontal distance is known to us, and what we actually need to compute is the line of sight. right? You know the angle of elevation, you know the horizontal distance. What you need to find out is the line of sight. Conversely, if you knew the angle of elevation and the line of sight, and you'll have to compute the distance, you know this value, you know the angle of elevation, what we are trying to find out is the horizontal distance. In that case as well, we'll be using cos theta. What is cos theta? Cos theta is adjacent side divided by hypotenuse. Adjacent side is BC, hypotenuse is AC. So what is BC and AC in heights and distances? BC happens to be the distance, the horizontal distance. AC happens to be the line of sight. So if you know the angle of elevation and if you know one of these two, either the distance or the line of sight, to compute the other, we'll be using cos theta. Lastly, when will we use tan theta? We'll be using tan theta when we know the angle of elevation and the distance, the horizontal distance is known. What we need to find out is the vertical distance, which is the height. You know the angle of elevation, you know the adjacent side, which is the distance, and you're trying to find out the opposite side, which happens to be the height. Conversely, if you know the angle of elevation and the height, you know angle of elevation and you know the height, you want to find out the horizontal distance. You know this, we're trying to find out. In both these cases, we'll be using tan theta. Tan theta is opposite side by adjacent side. This is the opposite side. This is the adjacent side. So if you know the angle of elevation, which is tan theta, and if you know one of the other two, either the height or the distance, to compute the other one, we'll be using tan theta. So you found out when to use sine, when to use cos, when to use tan. Let's put all of these together in this table. Definitely you know the angle of elevation. If that is known to you, line of sight is known to find out height. Height is known to find out line of sight. Then we'll go for sine theta. Angle of elevation is known. Line of sight is known to compute distance. Distance is known to compute line of sight. Then we'll use cos theta. Angle of elevation is known. If height is known, distance is to be found. Or if distance is known, height is to be found out. Then we'll go with tan theta. Right? So this is how heights and distances questions will be framed. We'll be solving quite a few examples to get conversant with this idea. You will definitely get 1 to 2 questions testing this idea in the board examination. You need to be completely thorough about it. Supercharge your math quotient. Sign up today for online CBSE math classes at online.maxtute.com. I'll repeat it. It's online.maxtute.com. And before you leave, check out the related videos and remember to subscribe to this channel.